In this video, we're going to be talking about sedimentary rocks. Please make sure to have your rocks flowchart ready as we're going to be filling in another portion of it today. Let's get started. Of course, as I mentioned, we're talking about sedimentary rocks, the second variety of rocks in our rocks chapter. Please recall that rocks are classified according to the way in which they formed. So, for example, igneous rocks form from the cooling and solidification of magma or lava. Now, sedimentary rocks form in an entirely different way, which I'd like to describe now. The general way in which most sedimentary rocks form is from the compaction and cementation of sediments. Now, there are some words there that we need to talk about. First off, compaction means what you might think, compacting, squeezing together. Cementation means gluing or cementing, sticking together sediments. But that brings up yet another question. So if these rocks are formed from the compaction and cementation, the squeezing and gluing of sediments, well, what exactly are sediments then? Well, sediments are the fragments, the little bits of rock that have been broken down as a result of a process known as weathering. Weathering includes wind and ice, running water, etc. So imagine you have a big boulder sitting in your backyard. Well, if you were to somehow magically leave the earth and come back 10,000 years from now, that boulder might look very different. As a result of years of wind blowing against it and ice cracking it apart and water flowing over its surface, it will have broken down into smaller and smaller pieces. That's what sediments are, the small fragments that result from the weathering of rock. Sediments, interestingly, are classified according to their size. So we actually have 6 categories of sediment sizes, the smallest being clay, then silt, then sand, then pebbles, cobbles, and boulders being the largest. So you've heard the term sand before. Now you know that it actually just refers to a size of particle, not a specific material. If you want to know the specific sizes that make sediments fall into any of these categories, you can find that information on page 6 of your Earth Science reference tables. You can ignore the graph portion of this chart as we haven't learned about it yet. However, I'd like you to pay attention to the names of the sediment sizes on the right-hand side that I've highlighted in green. They will tell you how big each sediment is. So let's use sand as an example. For a sediment to be considered sand-sized, it would have to be between 0.006 centimeters and 0.2 centimeters. Anything bigger would be a different type, as would anything smaller. Another example, boulders are considered any sediment that are larger than 25.6 centimeters in size. Now, let's talk about the first type of sedimentary rock, because there really are 3 types. The first type of sedimentary rock is called a clastic sedimentary rock. Now, a clast is actually just a fancy word for a sediment. So these are actually the types that we have already been discussing. These clastic sedimentary rocks form from compacted sediments, and these are generally classified according to their size. Let's take a look at the sedimentary rocks reference table. Now, the clastic rocks are the ones that are on the top half. They are also referred to as the inorganic, because they don't involve any living materials, and land-derived, meaning they come from the land. They come from the rock that makes up the land. Now, if you'll notice under grain size, you can see the different size sediments that make up each of the rocks. Composition tells you what minerals you would expect to see. Comments are just important information. And then, of course, you have the names of the rocks and something called the map symbol, which we'll be using more later in the year. So let's take a look at some of these clastic sedimentary rocks, beginning with the first one, conglomerate. Conglomerate is composed of all different size sediments or clasts compacted and cemented together. So you'll have big cobbles, pebbles, maybe even boulders, compacted with small sand, silt, and clay. Notice that the sediments in a conglomerate are rounded out, likely due to flowing water that ran over them sometime in the past. Very similar to a conglomerate is a breccia. Breccia, too, is made of all different sized sediments compacted and cemented together. The difference being the sediments in a breccia are not rounded. They are more angular, pointy, or jagged. Then we get to the sandstone. As you can imagine, sandstone is made of compacted sand grains. siltstone, made of compacted silt, and shale, made of compacted clay particles. So those are your clastic sedimentary rocks. Compacted and cemented sediments. Now, back to our chart. Let's look at another type. Let's actually look at the other two types. We have organic and crystalline sedimentary rocks. For the crystalline, we have things called evaporites and precipitates. And then for the organic, we have what we call biological matter rocks or bioclastic rocks. Let's talk about these, as they are a little bit more complex. First off, the crystalline rocks, seen here on the reference table. So these are under a column that says chemically or organically formed sedimentary rocks. So these are not necessarily from compacted sediments. In fact, the crystalline ones form in an entirely different way. So crystalline sedimentary rocks are known as evaporites or precipitates. And what that means is that they form as a result of some sort of chemical process. Let's take a look at some examples. This is probably the best example. This is rock salt. Now, rock salt forms from seawater, which of course has salt, or halite, dissolved in it. And when that water evaporates, the salt stays behind in the form of crystals. Those crystals are the rock salt. This is why it's called an evaporite. This is also why it's called crystalline, because it's crystals of salt that were left behind after evaporation occurred. We also get other rocks like rock gypsum and dolostone that form in similar ways. Just to mention the precipitate, this is a similar process, however, as the name implies, it does not involve evaporation like rock salt does. A precipitate forms when a water sample is completely filled with a dissolved mineral, so much so that the mineral falls out of being dissolved and crystallizes in the bottom of a body of water. To summarize, the crystalline rocks all involve some sort of chemical process, whether it's evaporation or precipitation. The result would be rock salt, rock gypsum, or dolostone. But what about these biological rocks, the bioclastic rocks? Now these form from compacted organic material or organic matter. We already know some examples of these, which include coal, which forms from compacted plant remains, and then this, which is a variety of limestone called a coquina. And you'll notice this is made of compacted shells. Shells, of course, are made by sea creatures. This is organic material, and so being classified as a bioclastic rock because it's organic matter that's been compacted together. One more key note about sedimentary rocks is that they are the only type of rock that may contain fossils or evidence of past life. So if you see a rock with a fossil in it, you know automatically it must be a sedimentary rock. The reason being, the processes that involve the formation of igneous and metamorphic rocks involve a lot of heat and or pressure. And so these processes would destroy any fossils that existed. Therefore, the only type of rocks that really commonly contain fossils are sedimentary rocks. We'll learn all about this in school. Thanks for listening.